So now that we've covered the features in the Completable Futures framework, what I want to do at the last part of this class, last day of the class, is go through the pros and cons of the Completable Futures framework. So we'll take a look at this and compare and contrast it primarily with the Parallel Streams framework because they provide interesting examples of duals. You can solve the same problem in multiple ways, as we saw with the image stream gang program that we show here. So some of the things that the Completable Futures framework does really nicely is it greatly simplifies the programming of asynchronous operations. In particular, it supports the dependent actions that are triggered upon the completion of async operations. As you saw, as you're seeing in the programming assignment, when things finish running, then the dependent actions, the completion stage methods, are automatically invoked. And this allows us to be able to fork, chain, and join asynchronous operations in a relatively intuitive way, as opposed to other ways of doing things with callbacks or more complicated approaches. One of the things I really like about the Completable Futures framework is it enables asynchronous programs to appear more or less like synchronous programs. If you take a look at how you program the software by using the mechanisms of fluent interfaces, you can see that as one thing finishes, you can directly connect it to the next operation to run. And so this looks synchronous in the sense that one thing happens after the other, but of course the operations actually run asynchronously. So it gives this synchronous veneer atop what is fundamentally asynchronous processing. And I think that's very powerful. Another thing that's really cool about the Completable Futures framework is that asynchronous operations can run concurrently in an open-ended set of thread pools. You can either use the pools that come with the fork join pool framework or the common fork join pool framework, or you can use various predefined thread pools, or you can have user-defined thread pools. It's really up to you to decide how the processing works. And that's really in contrast to Parallel Streams, which forces you more into a Procrustean bed of using the common fork join pool, unless you kind of stand on your head. Another neat thing about Completable Futures, which is also, by the way, the same benefit you get with Parallel Streams, is you don't have to spawn your own threads. They're done for you. It's done by the common fork join pool or whatever thread pool you decide to associate with the asynchronous processing. And you also often don't need to have any explicit synchronization. So if you need to synchronize, if you have things that might be accessed in parallel, then you might use something like a Java concurrent hash map or whatnot. But oftentimes, you don't have to put synchronization logic in your code. You can either avoid it altogether simply by using the asynchronous framework and passing results back through Completable Futures, or you can use mechanisms that are available in the concurrent collections that are part of the Java class library. So that simplifies a lot of accidental and inherent complexities. Another big win is that Completable Futures are often more efficient than Parallel Streams. Almost always the case. The example we looked at with our image stream gang program, if you were to run this thing and experiment with how it behaves, you would see that Completable Future implementations typically run faster than the Parallel Stream one does. And the main reason for that is that there's just less mechanism going on in the Completable Futures framework. The Parallel Streams has a lot more stuff going on behind the scenes in terms of splitterators and in terms of combining things with collectors and in terms of the whole framework itself. It just has more overhead. So Completable Futures are a little bit leaner and meaner. Obviously, your mileage may vary here, so you have to benchmark the code carefully in order to see what works. As we'll see when we talk about the cons of Completable Futures, they're more complicated to program, so that's the downside to the performance boost. But that's almost always the case. Almost always the case if you want things to run faster, you have to do a little bit of extra work. One of the things I like to do, and you'll see this in the programming assignment 4 that you're working on right now, is basically combining sequential streams and Completable Futures often gives you a win. So when you put those two things together, it's a nice improvement. Streams can be used to guide the overall flow of control, and completable futures are used to perform the asynchronous operations in parallel. So you kind of get the best of both worlds in that model. You don't have to do it that way, but it's a nice way to go. However, having parallel streams in completable futures is probably overkill. It really doesn't give you a win. It's just having too much parallelism for its own good, and those things in some sense would conflict with each other, so why bother? Okay, so that's an overview of the benefits of completable futures.